Hello and welcome to the presentation. My name is Christian Eichhorn. I'm part of the research group Augmented Reality of the Technical University of Munich. And my topic is shopping in between realities using an augmented virtuality smartphone in a virtual supermarket. This topic came into existence when we developed mHealth applications for a research project where we wanted to improve and basically make it more healthier, the shopping habits of participants. And we had these applications on smartphones and we sent people into the real supermarkets. We faced a problem that there were lots of influential factors. Just think about the rush hour in a supermarket compared to a nearly empty one. And so what we wanted to have is a virtual environment where we can control all these factors and therefore have a standardized evaluation environment for our studies. And so we settled out to building this environment, and we faced a second large challenge of how are we actually bringing the real smartphone into the virtual reality world. So what I will do is in this presentation, firstly, I will go over how we build the environment. For example, I will talk about layouts and products, and then I will go into the AV smartphone concept. This is the topic how we brought the smartphone into the virtual world. I will explain all the technology, the things that we had to solve. And then it's going to be about a user study with 30 participants, where we got really interesting results, for example, about usability or about presence, as well as we asked additional questions, and we even made some data analysis by recording some data when participants visited our market. First of all, I want to look at related work. So there have been other virtual reality supermarkets before, but often they focus on a small selection of products and not on a large scale supermarket itself. They often use other technologies. And so in, for example, some literature reviews, there were some issues and research gaps mentioned, for example, the missing focus on natural interactivity or multi-sensory devices, which we actually tackle, as well as when we look at other approaches of how bringing the smartphone into VR. There have been approaches, for example, relying on depth sensors, which bring artifacts. We chose a different route. So when we look at how our solutions compare to existing research, we have two tables. The first one is about other supermarkets that have been built before. We compared our solution, maybe looking at the size of the market or the products, as well as we have a table about comparing our AV smartphone concept to the other existing ones, for example, looking at technology. So if we look at our market and how we realized it, first of all, we look at the Unity scenes. We have two of those that are the main scenes that make up of our platform. The first is the configuration scene. We call this the dollhouse view on the market, where you can actually position shelves and place different products on them. And then what you can do, you can press a button and you can jump into the 3D world, into the virtual reality world, where you can then interact with the environment. This is done with the VR supermarket scene. I have a small video for you how this scene in 3D actually looks. And this is a replica of a German discounter. A German discounter can be described in a more generalized way as a medium-sized supermarket. And what we have put a lot of emphasis on is that the layout, as well as all the products in here, are very authentic, so that we can trigger the shopping habits of the participants when they go through this market. For example, what we definitely need is realistic German products. So if we look at the market here, we can see we have an interactive interior. You can, for example, open the boxes here from the freezer. Then we have this rich selection of localized products, which I will show you in the next slides, how we build those. And we have a full-size familiar store layout. This has been actually developed by visiting various real markets from one discounter brand. And then what we did is we generalized this so that even people who are not visiting this specific brand, which is one of the largest in Germany, that they still recognize this as a German discount environment. If we look at the products, we have an actual pipeline in Unity. We are not using some kind of asset packs. We're building all the products ourselves. We build this with cylinder boxes where you then can place these labels on them and have different colored areas. And we're using the data from the Open Food Facts API, where we get nutritional data, for example, to generate this nutritional label here, as well as where we get images of the products. We also get images from our partners from the research project, and we use computer vision through OpenCV, where we then can cut out parts of the image and rectify those so that we get labels for our products in the virtual supermarket. In another extension of this approach, we introduce primitives with which we can then build more complex shapes. What you see, for example, on the left side is we use a cylinder with a sphere, another cylinder on top to build this bottle. We can even build this squished glass here for this very specific product, so we can make these products very realistic. And this is what we call playing with blocks. So we put a lot of emphasis on layout as well as products. For example, even adding imperfections for vegetable and fruits. Secondly, the challenge is how we bring the smartphone into VR. We do this with an augmented virtuality setup. That means we have a little camera here for optical tracking, and we track for markers on the screen of the person's smartphone. So it's a personal device they bring with them. And what we also do is we use a concept called diminished reality, where we can hide the markers. And if, for example, the tracking is lost, for example, people are hiding all the markers or they move it out of the reach of the camera, we even have screen transfer for the self-built application that works on iOS and Android. We use UB Interact for the general communication between the smartphone and the VR environment. And we can even transfer the gyroscope data, making this rotation very natural, and the translation we actually get from the hand tracking of the Oculus Quest 2. I have a small video here as well, and what you will see is if we scroll here in the app, you see that the hand tracking is overlaid of the actual thumb of the image, and therefore it's a very natural and easy interaction for the user in the virtual world. If we look again on this, how the setup is, this is on the right side is the technical setup, and this is how it looks in VR. And you see here, this is the optical tracking with diminished reality. On the bottom, you see actually the live screen mirroring, where we use a TCP protocol to realize that with our own applications. So then we ventured out to actually evaluate our solution. For that, what we did is we want to find out how well is our AV smartphone received and how much of an advantage is this whole AV concept. So what we did is we actually built a fully virtual smartphone. That means you see it here, it looks very similar to the AV smartphone, but in your hands, there's actually nothing. There's pure air, and how you interact with this virtual representation that is tracked again by the hand tracking of the Oculus Quest 2, you're using your fingertips and you're just putting it in the hands, in the palm of your hand, and you will feel nothing. You have no haptic feedback, but with the AV smartphone, you have your natural device in your hand. And what we did is we actually built another fun part of this application that is a simulated AR scenario. That means augmented reality. You have a little companion that's only visible on your screen that navigates you through the store. This could be a real application later down the line that we have to evaluate in this supermarket simulation. And everything is the same for the virtual smartphone as well as the AV smartphone, because we're running the app on the real smartphone. The virtual smartphone is just this dummy here, and you just click on, you just touch your palm of your hand. There's nothing in your hand other than that, but everything else is the same, and you get navigated to your products. There's a small video here as well. You see, this is this little companion that helps you to go through the market. And this is basically the scenario. And in our user study, we then switch between groups, starting first with the AV smartphone or starting first with the virtual smartphone. And then we switch them, so both technologies are basically being used by every person. In the end, we have certain questionnaires, for example, the system usability scale, where we got really good results for the usability, as well as when we look at these values here for the AV smartphone specific, it was well received. We had a pre-study with an earlier implementation of our AV concept, and the final one that you saw in the presentation scores really well. If you look at the iGroup questionnaire, especially presence, spatial presence, as well as involvement, been well received, and also people were recognizing the market, especially they recognize even the brand. In our final user study, 76% or people actually detect a specific brand. And if we look at the question we wanted to answer, which would the participants prefer, the AV smartphone or virtual one, there's a clear direction visible. 70% would prefer the AV smartphone, and the rest would even switch to the AV smartphone if it would have for example, no jittering that by some participants was still visible. If you look at other data we recorded, every part of the market was visited. And another very interesting thing we could get out of the data is that, for example, with the AV smartphone, finding products was much faster and much more consistent. In the future, we want to look more at haptics, for example, introducing a robot arm that gives you a shape of a product. Also, we want to improve further the AV smartphone with the feedback we got, adding additional sensors, for example, the smell with our little self-built mini cave. So if you are interested in these topics in general and this simulation, please follow us, because we are looking to release this whole platform, meaning the environment where you can build these supermarkets, as well as the AV smartphone later down the line. Thank you very much for your attention.